Our first speaker is Malcolm North. He's an associate professor for forest ecology at UC Davis and ecologist at the U.S. Forest Service Pacific Southwest Research Station. He's a framer of landscape restoration concepts for the Sierra Nevada, as articulated in the GTRs 220 and 237, in which forest patterns and processes are linked, and focus from stand level treatments is shifted to how landscapes function. He has elevated the urgent need to manage fire to promote resilient landscapes and maintain favorable fuels profiles while overcoming the constraints on mechanical treatments in fire-dependent systems. In addition to leading research regarding forest and fire ecology for decades, Malcolm has been a mentor and inspiration for many rising and influential ecologists, primarily focusing on forests and fire ecology in California. And with that, we'll begin with Malcolm North.
All right, well, thank you for the introduction. If I'm not coming through or clear, I hope somebody will chime in. Otherwise, I will launch into this. And it's nice to be here and have a good turnout of folks interested in this topic. What I want to do is cover two papers, actually, that I've worked on with a whole bunch of other people. And hopefully these are going to address questions which are kind of central to this forum. The first one is, if I can get this going, I first wanted to, put some obvious context out there that I think all of us are all too aware of, is that when we're working with these drier forests in the western U.S., it's not a question of controlling the fire or keeping the fire out of the system. We have been kicked in the butt enough to know that fire is inevitable in almost all of these forests, at least the drier ones, and that a policy of suppression is very appropriate sometimes, but obviously has the consequence that if fire is inevitable, you're kind of kicking the can down the road, and you eventually have to deal with the fuel load increase and also the kind of selective pressure you're putting on fire, basically tamping it down until it occurs under extreme weather conditions. And often in those kind of conditions, we have unfavorable outcomes, both in terms of structure loss, but also the intensity, severity, and extent of the fire. And when I was working on a paper a while ago, I was digging through some of the kind of statistics that I think all of us are all too aware of, but the one that really jumped out at me when I was looking at the National Information Fire Center statistics is that if you look at fires since the 1920s, since fire suppression really became much more effective, and you look at the 48 states, the contiguous part of the U.S., 16 of the 20 largest fires have occurred in just the last 14 years. So there's certainly an accelerating trend of these large, severe fires. So because of that, back in, I think, 2010 or 11, I was asked to give a talk at a conference asked by Brandon Collins and Scott Stevens, who ended up as co-authors on this paper. And they just take on this topic of pace and scale. So the next few slides, I'm going to focus on this issue and focus on it on Forest Service lands. But one of the things I was really interested in is, how would we assess currently how we're doing versus what level of fuels reduction and fire used to be, like historically in California. So it's an imperfect measure, but certainly one way of assessing pace and scale is to say how are we doing currently in terms of our treatments versus how much of California used to burn historically before the arrival of Europeans. And so what you see here is focusing just on the Sierra Nevada and a pretty simple exercise in which the acreage is broken down by different forest types, and then there's a column that looks at both the kind of knee mean historical fire return interval and a high historical fire return interval, and then does it for Forest Service lands and National Park Service lands. But the take-home is basically in the circles, which is that on Forest Service lands, which I'm going to focus on here, you had about 487,000 acres or so that used to burn each year. And to put that in perspective, that's often about a third to a half of what burns throughout the entire part of the United States right now. And the only time we've ever come close to that in terms of the modern era in California was a large series of lightning strikes that happened in June of 2008, which ended up burning almost 500,000 acres as well. But you can see this concept of actually living in a state which would have had a lot of smoke in it and a lot of fire burning at any particular point, because this is just the forests in the Sierra Nevadas. This slide is, I went and worked with several people in the Forest Service and the Park Service and tried to collate information on how many acres were currently being treated. If you'll notice, the bottom column here is wildfires, and I wanted to put in there the years because that figure of 51,000 acres seems minuscule compared to what we've been experiencing recently with the Rim Fire and the King Fire and so on. But to kind of do apples-to-apples comparison and be able to have good numbers for mechanical treatment and prescribed fire treatment, this is the 11 years that I ended up focusing on. But you'll see that if historical rates of fire used to burn about 488,000 acres, you've got mechanical treatment coming in just under 29,000 and prescribed fire at just a little over 8,000. And wildfire, you definitely can say it's reducing fuels out there in the landscape, but of course it's not necessarily always reducing them in the way that we would like it to do. But certainly if you look at that 28,000 and the 8,000 acres and combine them together, you're at about 37,000 acres treated each year intentionally in the Sierra Nevadas out of that just under 500,000. That's a present rate of 8%. So it's more than an order of magnitude off of where we would want to be if we were trying to reduce fuels at the same level that used to occur historically. And there was one other kind of analysis we did here, which is basically saying, okay, if you're treating this many acres presently, how much of the forest can you treat before you have to kind of go back and start at square one again because the forest is growing and adding more fuels to it. And so you end up in that kind of situation like the dog chasing its tail after a while going nowhere, but going back in to retreat the stands that you've treated before. And again, a fairly simple analysis, but suggesting that at current rates, about 60 to 65% of the forest you'll never actually get to. And I always find these numbers a little bit depressing. I hate to, kind of bring them up in talks, but it was very sobering to realize that at least on federal lands, about 2/3 of the forest will probably never get treated or touched at this point at the current rate at which things are happening. So what we suggested was that you would treat areas and then move them out of active management and try to maintain them with fire, either prescribed fire or managed wildfire, because otherwise you're simply ending up expending all of your effort maintaining what you've got. And the response we got from a lot of folks, particularly within the Forest Service, was given the many limitations that are using fire, it's just not a practical tool on a large scale to be able to achieve these kind of objectives. And that mechanical treatments were going to have to be the way at which we would solve this problem, and that was the real way to increase pace and scale. So that kind of is the response we got to this first paper, but being a pain-in-the-ass researcher, I thought, well, okay, let me look at that question. Can we really thin our way out of this problem? So the second paper that I'm going to describe here in the next several slides, and Phil participated in this paper, was real help with it. We looked at this simple question of, okay, let's run the numbers, and again, look at Forest Service land in the Sierra Nevadas, and say how many constraints are there on mechanical treatments and how much do you have left to treat. So I'm not going to go into all the details of this, but these are the level of constraints in which we looked at biological. Do you have enough forest cover on the site? Legal, wilderness areas and roadless areas, you have to take those out. Operational, we kind of looked at what the limitations were from steep slopes and existing roads and whether there was commercial timber on there. And then administrative constraints, things such as spotted owl and riparian corridors and so forth. And one part of the analysis, I don't have time to go in here, but we kind of looked at these operational constraints and whether that made a big difference. And the take home here is that mostly, even if you loosen up the constraint on working further from existing roads or on steeper slopes, it doesn't substantially increase the amount of acreage that you can work with. So here is the first kind of take-home slide. These are the national forests working from north to south, starting with the Modoc on the left down to the Sequoia, and then swinging around to the Inyo, which are the last two histogram bars there. And you can see the total acreage, and then each one is kind of what's getting taken out, the brown being the not productive timberland, then wilderness, then operational and administrative. And so the green and the percentages there are what is the remaining percent of land available. And I also want to point out the co-authors listed on this paper at the bottom so that you can get a sense that this really was a team effort of a lot of people. But many people would say, well, that's not really a fair comparison because you got a lot of rock and snow out there. So this table focuses just on the productive forest lands, those that actually have kind of commercial timber on them. And here you can kind of see the take-home lesson is that legal and operational constraints drop each one of the acreages by approximately 25%, and then the administrative constraints drop it by about another 8%. And so it varies a lot forest to forest, but overall about 44% of the productive forest is available for mechanical treatments. But the figures vary a lot with a general trend of forests being much more constricted in the southern extent of the Sierra Nevadas and less restricted in the northern extent. So here I'm just going to quickly go through these slides to show what it looks like for the Sierra National Forest. This is what's mechanically available after you remove kind of the rock and ice. This is what happens when you remove the wilderness areas. This is what happens when you take into the constraints on access, operational constraints. And this is what you're finally left with when you get down to including or taking out the administrative constraints like the sensitive species and riparian areas and so forth. So the one thing that does make a difference here is that this kind of analysis, like anything, it's like real estate. It's all about location. And so we wanted to take this a step further and break the Sierras into basically a unit that was similar to a fire shed. So in this case, we looked at breaking the Sierra Nevadas into about 710 of these hydraulic unit 6s, which are roughly 20 to 40,000 acres often in size. But it's often a planning unit for the Forest Service as to where they would try to hold the line on a fire or be able to have a little bit of an effect on it. And then we used a modeling sequence in which a lot of Mark Finney's work suggesting that, you know, unless you have roughly 20 to 25% of an area treated, it's very difficult to be able to have an influence on fire. And so the take-home message here was that when you look at these 710 sub-watersheds, only 20% of them are lightly enough constrained that you could mechanically thin your way to success. And about 46% of them, you're just never going to get there. You're not going to be able to influence fire within those sub-watersheds with mechanical means alone. And then there's a moderate category, which in some cases you can achieve it with mechanical, in other cases you cannot. But to me, this was pretty sobering because it means that at least half of the kind of watershed, sub-watersheds out there, you just can't really effectively control with fire, with mechanical thinning it alone. So, and this gives you a sense of kind of a zoom in of what it actually looks like. The orange boundaries are the boundaries of one of these HUC 6's watersheds, and then the number in bold there, the 10 in the center, indicates what the percentage of land is that's available to mechanically treat. And when you go up and down the Sierras, there's a lot of these sub-watersheds that are below 20, that are down in this 10 level and so forth. And one of the things that struck us when we were working on this is that many of these places are not entered at all, period. Because they're well aware that you can't really thin your way into controlling fire in these sub-watersheds. But it really begs the question of, you know, are we passing up a large opportunity to establish an anchor in these places with some mechanical treatment strategically, and then rather than walk away from that sub-watershed, use fire as to build out from those anchors and really be able to increase our effectiveness within the landscape. And so finally here, the last take-home is that, at least for us looking at this analysis, is that mechanical harvest alone, while it can be very effective, there's a substantial amount of national forest land in which it's restricted. And furthermore, you end up in the case of kind of having high maintenance costs and almost all of your effort expended on maintaining mechanical treatments after a while. And frankly, mechanical harvest alone can't increase the pace and scale sufficiently to address the restoration deficit over the Sierras. But it might be thought of, rather than always as a tool for facilitating suppression and containment of fire, we might really think of it as a tool to be able to facilitate and build fire out into the landscape. Thank you very much.
Well, thank you very much, Malcolm. That is a sobering presentation on the magnitude of the deficit in fire on the landscape, and a very thoughtful rendition of the interplay between management and using fire, and some evolution in the thinking about the role of management. You ended on this point about really kind of facilitating the use of fire as opposed to just suppressing fire through the management. So this is all very exciting, and it reminds me very much of what we say in our project at National Forest Resiliency about the work being restorative, but more importantly, it's about setting the stage for the return of fire. So I open it up for questions. Malcolm got us right to schedule, so we've got 5 minutes. Other comments or questions?
This is Mary. Hi, Malcolm. I'm a staff team member of the Fire Learning Network, and sometimes we laugh, and I'll invoke the words of my colleague Jeremy Bailey, who says, why do we take these jobs where we just flatten our foreheads all the time on the wall? But the thing that I flatten my forehead about repeatedly is that it just seems like we could figure out how to do controlled burning at larger scales. And I imagine this, you know, a scene where you have a 50,000 acre fire, it's had all kinds of burn units prepped around it. You invest resources in helicopters and, you know, hose lays and lots of people and all that stuff. I just wonder if you could speak a little bit to whether you see any opportunities and challenges in pushing that kind of, I guess, awareness and practice.
Yeah, it's a great question, and easily could go into probably a whole day dialogue about all sorts of problems that there are out there for putting more fire on the landscape, everything from the culture of agencies to the litigious nature of the environment we work in. But at least a couple things I would certainly point out is, particularly in California, and I think in a growing number of places in the West, air quality regulations are a real significant problem. And I have not been involved directly in it, but kind of talking to people and working with some of these people who are trying to address that. And there is some movement to be able to get fire in forests considered as an exceptional event and exempt from limitations on smoke quality. That, frankly, for California and I think for other places in the near future, would be a huge game changer in being able to open up the opportunity to be able to put more fire out there. The other thing, which is kind of obvious is just that costs are much better when you're proactive about these things rather than waiting and then opening the floodgates of cash and treating everything expensively at the end. And I think if we could get politicians and the people who control budgets to realize that would also help.
I appreciate it. Thank you. I appreciate that.
Other questions, comments?
Yeah. Hey, Malcolm. This is Wendy. I was wondering if you're aware of other people doing similar analyses in other parts of the West. It seems like a really valuable exercise to inform policy.
Yeah, not currently. We did find a similar analysis that had been done in Arizona, which didn't find the landscape as constrained. So, you know, we were looking at approximately 25% of landscape being available, and I think the number in Arizona was more about 50, 55, or 60. And so you know, it raises a great question is that these numbers and levels of constraints are going to change a lot geographically depending on a lot of things, but particularly how rugged the terrain is and how much wilderness area there is and so forth. So these numbers are probably, you know, applicable to mountainous areas in the West, but obviously wouldn't apply very well at all in the Southeast or even more gentle terrain.
Yeah, Dr. Carrie Medlin in the Rogue Basin with the Nature Conservancy has taken a different approach using the land fire proportions of several structural states to look at the deficit across those different proportions, and then has found very similar results in terms of the amount of ground that is available and treatable, highly varied landscape. Carrie, I didn't know if you wanted to add any comments about that.
Carrie, we can't hear you.
None.
If you might be on mute.
I have a note from Carrie that says his audio is not working well. We've got just a couple more minutes if there's another question or comment.
Eitan typed a question into the chat there about, can you describe how you use the term fireshed in this analysis?
Oh yeah, I see that. Okay. So, you know, we were building off of a concept that had been looked at by, and people on this phone call may know better than I, but I think Bernie Barrow was one of the leads on it, in which there was an effort to try to define kind of coherent units in California in which you would plan for and think about fire and kind of treat it as you know, an unofficial but kind of management unit in which you'd either try to hold fire or realize that if you had a fire within that area, that most of that landscape was kind of linked to the fate of the fire burning. And so when we were trying to look for something that we could use at a level that was somewhat similar, you know, frankly, if you have local people and you're sitting down with a map, you're going to get a better definition on these than we were working with. But these hydraulic unit 6s are really not bad as kind of a quick and dirty because you do frame out a coherent unit which is defined by the ridge tops, which is often where people are trying to hold the fire. And also they're at about the size in which if you get an ignition, the fire is likely to burn a substantial part of that particular watershed before you really have a good chance of being able to contain it or control it. So imperfect, but the idea is that you're defining an area in which you know, you're kind of all in the same lifeboat, and if you get an ignition, you're likely to have fire spread extensively throughout that area before you have a good shot at being able to contain or control it. That's kind of the